Welcome to CppChat, the only C++ podcast taking place at this conference other than the other one as well. So yeah, we're going to have to work on that intro a bit, I think. Today we're going to welcome... Today we're welcoming Herb Sutter, who's been kind enough to join us, and we're going to interview him.
Wonderful.
John, are you going to do a disclaimer, or are we going to...
No disclaimer. We're here, we're going to have fun, and no disclaimer today.
Okay, so don't you like there's no safety net?
That's right, no safety net. So, first question, obviously. What do you think of the conference?
Oh, this is great. I mean, I have to say, CppCon is always my favorite conference. It has been since the beginning. Thank you to the many people who organized it and made it that, and the community and the spirit. Since we started this, I've always aimed for a festival for C++, as the way people would feel and describe it, and to see people over the years describe it like C++ Woodstock is like, that's exactly what we were going for. And several people told me this year they actually liked this one the best of all of them. Just the energy, and that's saying a lot compared to previous years, so I've just had a blast this week.
I've gotten that too, and I'm sure people think, well, yeah, I'm sure you get that every year. It's like, you know, every iPhone is the best one we've ever made, right? But no, I felt that differently. I mean, people have come up and said, no, wow, this one's the best. And I kind of feel like on the organizer side, we're kind of starting to hit our stride a little bit. We've got some major challenges ahead of us. We'll be talking about that stuff later.
But it wouldn't be possible without all the volunteers and all the attendees, just the spirit, the community spirit, right. And we're just trying to get better every year, and we thank all the help.
I tell people, I love it when someone comes up and says, wow, conference seems to be running so well, because as an organizer, I see every problem. And even if a problem's solved, because someone will come to me and say, John, we had this happen, and this is what we did, and I think it's okay. Because I want to know. I mean, that's the right thing. But it means that when I think of the conference, I think of all the things that went wrong, because that's what you focus on. And then I have someone come up and say, everything's running perfectly. And I just smile and say, the success of this conference is based entirely on the ignorance of the attendees.
No. It's entirely on the experience of the attendees.
That's right,
so thank you for what you do to make it that way. The kids are all right.
That's right. That's exactly right. No, it's been great, and I'm really glad that you're enjoying it, because that's important. That, I mean, this is a foundation project, and we're wanting to promote standard C++, which is what the Foundation's mission is, and I want to make sure that our conference is doing that.
You're going to hate me.
As well as having a lot of fun. Yeah?
You're going to hate me.
Yeah?
But I'm deliberately going to say it's nice that we're closing out here on a high note, because it's sad that this is the last CppCon.
This is the last CppCon.
In this location.
Yeah, that's right.
But you'll talk about that more in the plenary session this afternoon.
That's right. At the end of the...
That was totally a joke, right?
Yeah.
It was true, but a joke about it.
At the end of the panel, we will announce where we're going next year. I'm excited. Herb and I discussed this and said, well, we could announce at the welcome, because I don't think the secret will keep well, because a lot of the volunteers know where we're going. There's a lot of people who actually know, and we didn't want everyone to know because we kind of wanted to make a nice presentation about it. But we discussed it and said, if you say it at the beginning of the conference, it takes away from this conference, and we didn't want to do that.
We're here for this week.
We worked very hard for this conference as well. We've been looking ahead. There's no question about that. But we've been looking ahead. Really, I think we did our first other site visit back in 2015. We've been looking ahead for a very long time, and I'm excited about where we're going. But in the meantime, of course, we have every single conference has our full attention. Yes. They have 100% of our attention here and 20% of attention somewhere else.
So C++ news. I haven't been watching it as much this week. A lot of the news has been at this conference. I've been enjoying from the speakers.
We are the news.
We are the news.
Well, but the speakers and the talks and the panels that have been happening have been really great.
Yeah, absolutely. I don't think there's been anything else that I've seen.
Any particular ones
of these walls?
Any particular ones that stood out to you?
Unfortunately, because I've had so many talks and other things going on myself this week, I've not been to many of the talks. I saw yours.
So your talks, those are great.
Oh, my talks were perfect, of course. They were among the best I've seen this week, definitely. I saw yours. That was excellent, of course. It's great to have an update on those things. And I think the other highlight was seeing Simon Brand emptying a cup of water over his head on stage.
Okay, great.
If you don't know what I'm talking about, you'll have to catch the lightning talks from last night when they're out on YouTube.
We did have a talk. Someone came to me and said, "Well, we did a literal Socratic method. I was playing. This was someone else telling me this. I was playing the newbie, and the person presenting with me was actually dressed up in robes like an ancient Greek." And I said, "This upsets me. If you had told me in advance, we'd have a photographer there." You know, visually, most of our talks aren't that interesting. I think the talks are interesting, but they're basically a person standing by a lectern showing code on the screen. It's not very visual. If you've got anything visual going on, please let me know. I'll have a photographer in the room, and we will catch the visual interest. And it was kind of like, he said, "Oh yeah, I guess we should have done that, shouldn't we?" Well, yeah. But I guess that was caught on tape then.
Hooray for YouTube.
Yeah. Hooray for YouTube.
I do wish we did have a camera on Matt Godbolt's face when you did say that this was going to be the last CppCon. Just for a moment there, he was shocked.
Yeah, I did have somebody last night someone who's been at every CppCon said this is the first year that they felt that every single one of the plenaries was great. Of course, they haven't seen Chandler's yet, but I can't imagine Chandler's not going to disappoint. Chandler is never disappointed.
No, I just love the way you said that.
Yeah, but no.
Chandler? Yes.
Yeah,
you'll do great.
Chandler. Yeah, no,
break a leg.
Chandler is not going to disappoint. He's never disappointed. But I mean, I think that's the kind of thing that we've got this year. It really has been strong. A lot of really good feeling here. A lot of excitement. Everybody's great.
Yeah, Kate did a really good job. Yeah. I mean, it is so great to hear more people talking about simplicity.
Right.
And the importance of simplicity. Because these days, just like she was talking about writing code and I was talking about extending the language, but many of the same principles apply in both cases. We're at a point where, yes, there are still some features we need in the language. Yes, there are still some things you need to write your code more decoratively or more intricately. But more than anything, we err on that side, and what we really need is how can we make this simpler? And because it's easy to write complex code.
Yeah,
it's a little harder to write working complex code.
Right.
But it's easy to write complex code. What's really difficult is writing elegant, maintainable code.
Right. Yeah. Someone once told me that they had, as part of their interview process, they would ask candidates to. Someone had heard that only 10% of CS graduates can actually write a correct binary search algorithm. And there's this company that said, well, we want to hire out of the 10% that can. So part of their interview process was write a binary search algorithm. And they said that they got PhD candidates that would turn in 3 pages of code. And they didn't have to look at it. If it's 3 pages long, it's not right. I mean, you just can't be, right? I sat down as a challenge, said, okay, I'm going to do this. I'm going to write an implementation of lower bound. And what does it take? And I think it's like 14 lines, at least that's the way I wrote it. Something like that, 14 lines. And that includes, all the braces and things. And the point is that if you try to catch all the corner cases, then you're creating corner cases on your corner cases, right? I mean, you have to write the code so the code naturally handles all the corner cases correctly. And if you do that, it's not very long. Yeah, it's exactly the same. It's very easy to write complicated code. It's just hard to get it right.
It's interesting that you say the binary search and data structures. Sometimes people ask me, like, what's the most important course that you had at university, say, or the course that you've taken? And to me, it always comes to 2. The number 2 one was data structures. That's just, everybody should be forced to take that in first year. It's not usually first year, but that's just so important. But the number 1 one, which covers what you said, the number 1 one was a course I got to take in comparative programming languages, where every week or 2 we did an assignment in a different language. And I'm not talking different like C, C++, C#, Java.
Right.
For this course, that was one language.
Right.
Like, because they're all pretty much the same.
We're talking about Prolog.
Exactly, Prolog. Everything is a rule. Assembler,
right.
and write an animated banner in assembler. Lisp and like functional languages.
Yeah.
Like, that will kick you out of your world of, oh, my basic code is pretty much what everybody writes in. Just sometimes they use curly braces.
Yeah.
And it forces you to think about it. Now you may not write a lot of production code in Prolog, but it forces you to think about, okay, programming is more than just one thing that I learned in school.
Mm-hmm.
Someone was talking this week about using Prolog as a build system language. So maybe they will be writing production code in Prolog.
Well, a lot of people do. I didn't mean to denigrate it. It's just we might never do it because it's a smaller fraction compared to some other languages. But yes. And it's really great to see language innovation, seeing more languages come along, exploring different things. Those languages can succeed, or they succeed in informing existing languages. C# and C++ have stolen lambdas from the functional languages. And that's perfectly fine. You can use lambdas in an imperative language without being totally functional. And the idea of immutability with side effects, so the immutable data structures. Wonderful concept. So the synergy among programming languages is great. Having said that, it's true that there have been, I forget the exact number, but it's well over 10,000, depending how you count, programming languages invented. When you look at the number that ever see widespread use, that is a very low success ratio, depending how you define success. Because was it Edison who talked about, well, yeah, I failed 1,000 times. I just discovered 1,000 ways it didn't work. That's progress. And Bjarne is very quick to say, yes, fine, we found out this doesn't work. We broke it. Great, because now we can move on and try the next thing. And so experimenting is very important. And I'm just curious, how many of you, like even just as a side project or just as a report generator for a particular project or something, have ever written your own little language and maybe a little compiler or interpreter for it? Aren't you more enriched? So about half the audience. Aren't you more enriched as a programmer from doing that?
For those of you who are listening on audio, there's about 800 people in this room.
Give or take a 0.
That does remind me, though, I do have a bone to pick with you. In your plenary session, where you talked about your efforts to simplify C++, you touched on but didn't go into your work on exceptions. Are you ready to talk about that publicly yet?
Oh, well, it's a public committee paper. I've never given a talk on it yet. I'll probably do that sometime. I have several projects in flight, and I haven't had I only give about one talk a year, so I haven't had the bandwidth to talk about them yet. And that's also still very early. It was something I'd intended to bring more like next year, but I've been thinking about for several years, but not bringing forward, except that there were several proposals trying to solve that same problem going different ways, and I thought, okay, this is the time to bring a contribution because we don't want to further bifurcate the situation that we're in. So let's see, and that's a big rock to push up a hill, and it's still at near the bottom of the hill with a long way to go. So there's lots of time to talk about that, and I hope it'll go somewhere. Most experiments fail. And so if I get a 50% success rate for proposals, I will be doing astoundingly good, and I will be super happy for the rest of my career. I doubt that will happen, but that would be great.
We had an episode where we discussed this. Did we have Arthur on to talk about this, or who did we have on to talk? I don't remember who we had on to talk about it, but I am so excited by this. You know, I kind of, early on when I started doing public speaking, I kind of was associated a lot because I have a very long talk on exception safety. And I believe that exceptions are underutilized in our industry because a lot of people won't use them for bad reasons, but there are some people who aren't using them for good reasons. And it really does kind of, you know, drive a wedge between everybody who's using exceptions. There's a certain way you can write libraries, all these kinds of things, and then the people who absolutely for good reasons don't want to use exceptions are locked out. And if we could come up with, and it looks like to me your static exception proposal, wow, it just gives us the advantages that you get with exceptions, and the advantages you get with exceptions is just really clean code that you can write without cluttering the code with all the failure cases. The failure cases get handled. They get handled, but they get handled, you know, at the detection and at the handling end, and nothing in between has to worry about it. And it's just a brilliantly wonderful way to write code. But the initial implementation of exceptions was too dynamic. There's some overhead there, memory allocation, and all these kinds of things. And a system that you've been proposing, I'd love to get you and Niall back on when we have a full hour and can dive into that particular topic.
And in fairness, not everybody agrees on this. This is a very early proposal. There are some people who are very skeptical, and they are right to be, about, well, do we really need to make a significant change to a language feature? It's not replacing it. It's just saying, okay, let's make the type static instead of dynamic, and then we can do the following. Do we really need to do that, or do we just need to try harder to optimize exceptions? Because the reality is that there are optimizations for exceptions that have not been done, and we could do better. And so the answer I typically give to that is twofold. First of all, optimizing, changing the constant factor isn't what we need to do. The key problem is to change the upper bound, to make them deterministic. And people say, deterministic, okay, it makes them faster. No, no, no. A hard real-time system needs you to know that throwing an exception will never, ever, ever take longer than X. And a constrained system that has no virtual memory needs to know that throwing an exception will never, ever, ever take more space than X. So it's not just about real-time systems, it's also about fixed memory systems. And so you got to drive into people's heads. It's not just about, oh, exceptions are slow. That's true too, and they create overhead in the binary image. That's true too, and we should fix both of those things. I think both of those would be enough reason to do this. But to really get to the heart of why, the best, strongest reason why we must do something is because they're not deterministic. And this is a deterministic language. This is a language where summarizing those first three, the three things that make C++, C++ yesterday in my talk: zero overhead principle, don't pay for what you don't use. Exceptions violate that today. I can write it better by hand. And a large fraction of the community does. They vote with their feet. That's data. We should not ignore data. But the second, even more important, is determinism, that I always have control over space and time. That is a reason why a large number of systems can't use exceptions. So we got to fix that. And coming back to the argument, oh, we should just optimize exceptions. Fine, that would improve number one. It does not address number two unless you put a hard upper bound. So optimizing is not the answer. So once you drive the conversation to that, it becomes clearer. And the second reason that the second thing to point out about it is people will often rightly say, well, do we need to have something different? Because what we've had is enough. Point out that we've succeeded where we've been static. So Bjarne made static dispatch the default. He made static typing, static compilation, static linking. And it's where we've gone to dynamic that it's worked well when it's an opt-in, never when it's the default. And you look, there's exactly two major language features that are inherently dynamic: exception handling, RTTI. Those are the ones that every compiler has a switch to turn off. Those are exactly the two. This is not an accident. So the way to address these is to do what has worked for us for 30 years. Make them static. How can we sprinkle static on them? Make the type of the exception static. Try throw catch, still there. We love that model. Please just make the type static. Guess what? Then we can do a lot of compile time. And with RTTI, we're actually already on the path for that, because RTTI, the type ID part in particular, like I said yesterday, we're getting compile time reflection. As soon as we get that in the standard, I'll be going, and now we deprecate type ID. And actually, can we remove it from the standard? Not just deprecate it. Actually excise it so that people are not, compiler writers are not required to support it out of the box, because we have a better replacement. So I think static sauce is our special sauce. And dynamic is good. We still added some dynamic things. We added stood any. That's fine. We added stood variant, which is statically typed, but dynamic, but it is a limited dynamic typing. Those are great, but they're opt-in.
Yeah, they're library and they're opt-in.
Yes.
Yeah.
And that's don't pay for what you don't use.
Right.
And then when you do use it, great, I have a library or I have a feature that is as efficient as I could have written by hand.
Well, I think one of the hints about this is that we deprecated the syntax of saying throws and then lists the type that can throws, and went instead with no except. And the point is that the original idea of exceptions is that the type being thrown is really important, and it turns out no, the type being thrown is really not important at all. Whether or not something is thrown is what's important, and that's when I give my 3-hour-long exception safety talk. That's an important thing that I say, is that you might think that knowing the type that's thrown is important. Well, it is. When you're doing the handling, you can process that, but it's almost never the important thing. The important thing is just that an exception was thrown, and the type is much less important. So
And
I think
it still carries information.
Oh,
but
absolutely.
But you
absolutely.
don't have to make the type carry that information.
Right. Yes. Yeah. When I was talking about how some people have good reasons for not using exceptions, I think there's a lot of fear, uncertainty, and doubt. A lot of people don't want to use exceptions because they're still writing C code and they don't want to admit it. But there are people. I have a friend who told me, he said, in my system, I have a time window. When I'm called, I have a time window. I guess the model for exceptions has always been that if you're processing something in a loop, we need to be fast. And if you hit an exception, you're out of the loop. It doesn't really matter what your time is. And for 99% of the time, that's true. But he was one of the situations, he said, I have a time window. I have to respond in so much time. I'm allowed to fail. It's okay to fail. But I cannot exceed the time window. And throwing an exception may not exceed the time window, but he has no way of knowing.
Yes.
He can't control that.
Even if at 99% of the time it doesn't, that's not good enough.
Right.
It has to be guaranteed to never
Right.
do it. And one thing I forgot to say about that is one of the reasons it's important to hone in on no, don't just optimize exceptions. Like, do that too.
Sure.
Great.
Great.
But that doesn't solve the problem. You need to make them deterministic, fixed upper bound in space and time. The reason that's important is A, because it's critical, and B, because everybody recognizes that is an unsolved problem. We do not know how to do that with dynamic exceptions. The closest you will find is papers written by Bjarne Sturstrup. There are 3 of them, and some of them are limited specifically to a fixed time, constant time dynamic cast. But you need that for exceptions today, basically, is a nutshell. And there's like a couple of follow-up papers. And these are from 2004, 2005. In one of them, Bjarne specifically says, and I have the quote in P709, not cheekily, but just, here's reality, where he wrote, I cannot recommend exceptions for use in hard real-time code because there's no known way to make them deterministic. He also says, I expect this problem to be solved by the end of the decade.
Did he say which decade?
And we are now about 14 years after he wrote that. And there is no serious suggestion or even idea for how to implement that with dynamic exceptions. Now, by the way, he does, in that paper, he and his co-authors do show how to do it with today's dynamic exceptions if you don't do dynamic linking and your type hierarchy is never more than this wide or this deep. It's a whole, and that, which fails for all the reasons whole program analysis fails as a general solution. You can't, it's great, but you can't appeal to it as the solution to anything because you can't rely on it. It doesn't scale. So that's the best we can do. So if you don't like the proposal to make them static, show me the alternative, because there is nothing on the table right now to do it with today's dynamic exceptions. Nobody knows how to do it. It's an open research problem that nobody's made any progress on for 20 years.
Yeah,
at least 15 years.
It seems to me someone could object to the proposal specifically on the grounds that no, that's not the way to do it this way. But someone saying we shouldn't go static, that somehow either dynamic exceptions are good enough, that's simply not true, and we don't.
They are good enough for some of the community, but not all.
Yes, I mean, good enough for the standard, that's the problem. Are they good enough for the standard? Are they good enough to be used universally? And that's what I say, like I said, is the poison. Suppose I want to write a library. How should I handle errors? All libraries have to handle. Most libraries have to handle errors.
That's true. Not all do, actually. That's true.
So how do I handle errors? Well, the best way, the cleanest way, the thing that makes the most sense is to use exceptions. But now some part of the community has to opt out of my library. So I either want to support everyone and use a clunkier, less nice error handling. My code doesn't look as nice. There's real possibility of overlooking errors, both internally in my library and users of my library. Or I can opt into a much cleaner, nicer, better designed solution of exceptions and pay the price that some potential users, people who might want to use my library, can't use my library. A solution like static exceptions allows us to say, no, this is the way forward. And everyone can do. I mean, one of the beautiful, wonderful things about software is how software we can build on it. I used to work at Amazon, and one of the things that Jeff Bezos talks about is that in rocket science, which is a hobby of his, when you put a new component on the rocket, everything about the component is important. The weight, the balance, everything about it. Whereas in software, we don't. All we care is the interface. Go implement it any way you want. I don't care because it's completely hidden for you. All I want to know is how do I call it? How do you respond? Maybe the time you take is important. I mean, there's some things, but I really don't care what you're doing in there. But that is the composability, as you said. Software composes, and we want to be able to have that. It's a critical, important feature of the fact that we build these really complicated systems. How can you possibly build these complicated systems? It's because the person building the complicated system knows absolutely nothing about Unicode, but he has a Unicode library. Knows nothing about fill in the blank, but there's a library and it's all composed so that nobody has to understand everything. And if the error systems don't compose, then it just kind of all doesn't glue well.
Two thoughts on that too, because we say, and I think it's a good shorthand as we're learning how to use the right words about things. At first, the title of the paper is still Zero Overhead Exceptions, which is, I think I'll keep that title probably because it's the key why. But the what is, when we say static exceptions, that's actually good. I try to say statically typed exceptions versus dynamically typed exceptions, because they're still somewhat dynamic. They're still runtime values,
well, yes.
But they're not dynamically typed.
Yeah.
And that's why you immediately say not dynamically typed, no RTTI, bingo. And none of that uncertainty, because you know exactly statically when you're calling it what the types are, and that means you can fold them into the return channel and so forth. Mm-hmm. Probably the biggest, and the second thought is probably the biggest reason, which you just alluded to and you did too, was why this is a problem, is because it bifurcates the C++ community. And the way I think I put this in the paper, or I put it in somewhere in descriptions about it, is that when you have a large fraction of the community, 20% that ban exceptions in their whole projects, according to the survey we did this year, which Bjarne doesn't have data, but viscerally agrees with. We've talked about this privately many times. We both agree on the data and on the feel for that 20%. And another 30% that ban exceptions on parts of their project, according to the survey. Those people, and I put this in air quotes and in print in real quotes, those C++ projects are not using C++.
Right.
They're using a dialect that is incompatible.
Yes,
because,
that's the killer. Because
it means that any constructor that can fail, you can't do that. You have to use a factory function. Any operator that may fail, because those are the two cases where the signature gives you nothing else, nowhere to put an error code, constructors and operators. If you use an operator that can fail, you don't overload an operator. You give a named function. So you're actively saying don't use a couple of language features. And constructors, maybe less so operators, but certainly constructors are pretty fundamental. And you're saying don't use those is a big deal.
Yeah.
And then you end up where we are now, which is we have standardized a file system API. I'm sorry, but this is just outrageous, even though it's well motivated. And it's like, I'm not criticizing the work of the committee. It's the best they could do with what they've got. It's the best we could do with what we've got. I support the decision. I'm just angered by it, that we are shipping a dual mode API where so many file system functions, there's one that throws an exception and here's one that gives you an error code. That shows you don't have a good answer.
Yeah.
That is a bloated API. That is an API that is hard to use consistently. That is an API that is hard to use in generic code, because now generic code doesn't know, well, which one do I do? Part of the world reports errors this way, part reports errors this way. I can't write a template that does it both ways. I have to pick one.
Well,
and then I can only use, and then of course, at least they provide both ways, so I could use it in a generic template that does it one way or the other. The reality is most types that people write use one or the other, and now I have no hope of writing a template that can use them both. Because the calling code has to be different, and that's what you get when you force the injection of a language dialect, an incompatible dialect. And this is a real problem. And I love that in the SG14 reviews, so I've got a whole bunch of verbatims from those, several experts from several industries actually used almost the exact same verbatim words, which were, great, we can finally come back into the fold and use real C++ because we've wanted to use exceptions. And we sort of use C++, but now we know that we're not really using C++, and we would love to be able to use it.
Well, even projects that didn't ban exceptions, this is one of the things in my 3-hour C++ exceptions talk. I would say there are times when you expect an error. So it's not really an error. In other words, I had a project once where we would check to make certain that a directory didn't contain a certain file, because if it did, then it didn't. Then we didn't get the right place here. And so it wasn't a logic error, it was a runtime error where something didn't get cleaned up. So we tried to open the file expecting it to fail. We wouldn't want to throw an exception there because it wasn't exceptional. But technically it was an error code from the call. And so I would say,
Status code.
in your, it becomes just a status, right? And so I would say, in your API, you need to think about this, that you may have the exact same call in two ways, because even in a situation where exceptions are acceptable, it's not really exceptional. It's actually expected. Well, it's as if I'm reading from a file, when I get to the end, I can't read anymore. And that's how I detect that I try to read and I fail to read. Oh, I guess I'm at the end of the file. Is that an exception? Of course not. Every file you read is going to eventually hit that.
It's a classic example, and if you're a low-level code like that, you should just be reporting a status code because you don't know if it's an error yet, failure to achieve post conditions of your caller, because it depends on the caller.
Right.
So you have to just document it as an optional result, unless you have a function that guarantees to give you an open file. Sure, then throw an exception because you didn't do that. Right.
But the ability to then turn that into a fixed time deterministic cost, a low cost alternative, then your status can just be an exception and it's no big deal.
Yes, you could do that. I am sneakily, not trying to hide it, but it is not an emphasized part of the proposal. I am actually trying very hard to specify this std error object, which is basically an evolution of std system error or std error code, this error code, so that the characteristics are it's 2 words wide, trivially relocatable, etc. But one little detail is there is no value 0, none. I never, ever, if I can get it, and I won't die on this hill, I'll give it up if I have to, but I would like to see an error code that never represents a non-error. It is always an error. If it was a success result, you should be returning a value.
Right.
Just an alternate success. But an error code is an error. It is not success with info. Like, oh, okay, I couldn't fill your buffer, but I filled a smaller one, and you can try me again. You can keep going. That's not an error. That's just an alternate success result. Error should never have the value none. So I'm trying very hard. Fortunately, Niall agrees, but we'll have to see how it progresses in committee, and I can.
Somebody will come up with a use case where that'll make a lot of sense.
Matt's showing something I can't read on his phone that apparently relates to that.
It's an error with saying no error occurred. An error dialog.
An error line, yes.
Yes. So let's.
That's almost as good as the dialogue that comes up and says some error occurred, right?
I like that one a lot better, just on philosophical grounds. Still could use improvement, don't get me wrong. But the idea of and let's be very crisp. If you're reporting an error, it's because you failed to achieve post conditions. End of story. That should be the whole story we teach. It turns out that if you then add but it could be none, you have now increased by about an order of magnitude the stuff you have to teach, because you've opened a small Pandora's box of interactions and exceptions that affect how you write your code.
Right. Either an exception's not thrown, or an exception was thrown, but the code was 0. And that's the same path. So, why is that the same path?
And philosophically, it's the same thing as Bjarne has said for many years, which is, please don't abuse exceptions because it happens to work to return a success result. I'm doing a recursive find. Oh, look, I found it. There, success. And I'll throw an exception to unwind. I'm seeing people in the audience going, oh, because you can, but you shouldn't. That's a success result. Return it. I'm sorry, that programmer was being lazy. Worse, they were being clever. Which is far worse than lazy, and lazy is pretty bad.
Yes.
Exceptionally clever.
Exceptionally clever, yes.
So you're in these embedded industries. So
have been.
Yes, you have been. You've got a background in several of them. So what's your take on the things we've been talking about?
Well, I'm a big fan, as you know. I've done a few talks on it already. My one criticism with your proposal, actually, touches on what we've just been talking about, is the use of the word exception. because now you can use these in non-exceptional circumstances where it's still an error, but it's an expected error. And I think that we've been saying for years, you should only use exceptions in exceptional cases, and it's become a self-fulfilling prophecy. That's why we've optimized it that way. But with this, we can stop saying that because we can use it in something that's closer to just normal control flow. And I think the word exception gets in the way of that a bit. It's not a big problem, but it's mainly nitpick, I think.
And it's interesting that you mentioned the advice, which we've given for many years, use exceptions in exceptional situations. That has always been vague and hand-wavy and subjective and imprecise, and we've sort of glossed it because it's the best we could say. I really want to come back to that definition of error. Error means you couldn't achieve your post conditions. That's it. And you might have, okay, used full buffer, used a partial buffer. Those are various successes. There's alternate successes. But if I couldn't achieve any of those, like host not found, that's an error, right? Exceptions or error codes or any of those should be used only to report errors. And if you stick with that, which is agnostic to error reporting mechanism, it's true for exceptions, it's true for error codes, only report failure to achieve post conditions as an error that is precise, it is clear, it has exactly the same effect of only in exceptional situations, but you can measure it and talk about it and it's definite. And so I always describe it that way these days because I also wrote about exceptional situations, but that is vague and hand-wavy and imprecise.
Yeah, well, you wrote exceptional C++.
That's true. It's kind of followed me around.
Well, you did follow up with more exceptional C++.
I followed it.
And an exceptional C++ style.
There might be a pattern there.
Well, we're looking for the book that's the exception, I guess.
Has anybody watched the new Netflix series Maniac? Just dropped last Friday, right before the conference? Okay.
How many hours in your day?
Well, I was sick, so.
Oh, that's right.
It was only 10 episodes. I think I've watched
yeah.
like the first couple of them. There is a pattern. So the joke is from Maniac, is that there is the pattern.
Yeah.
Yeah, I want to thank you for braving. Yeah, you were pretty ill, and I don't know, pretty ill, but you were under the weather.
Oh, this was much better than last year. Last year I had the flu during the conference.
Right,
this time it was the week before, which was great. Well,
not great, but worked out better. Let's say it that way. Yeah. So, what's the status of this proposal in terms of? You did allude to the fact that some people in the embed industry, who I think are the most important people to get over. And there's no point in doing this if people in the embedded industries aren't going to buy into it. So we aren't getting anything by getting, the normal application developer that's already using dynamic exceptions switch to static. Yeah, that's great. But if
but their executables get smaller and faster incrementally, they benefit too, just not as dramatically.
But yeah, and they only benefit in the failure cases where they already don't compare.
No, their binary image gets smaller.
Well, that's true.
And their executable gets faster.
Only faster in the failure cases.
Windows x86.
You've seen this.
No, Windows x86 is the non-table-based exception model.
That's right. That's going to help them.
Some will get faster.
Yeah. No, that would help a lot.
Yeah. But as for the status of the proposal,
so
there are 4 parts to the proposal, and normally I would decouple those into 4 papers, but they are related, and so I'm resisting decoupling unless necessary, but I'm giving them different major section numbers, so it's clear that they're orthogonal, but they are related because it's really looking at, okay, let's take a look at error handling in C++ all up.
Yeah.
Because it's very important. I mean, you can make mistakes by looking at just a narrow. I'm going to solve this part of the problem without looking at the whole thing. And so it tries to enumerate 4 major things. One is being able to say, opt into, I throw a statically typed exception. Because then we can optimize that for you. That's basically the core proposal. The second is, by the way, we ought to use, and that one has been seen by SG14, and they love it, but it has not yet been seen by the core groups in the committee, such as Evolution Working Group. We're focused on C++20, so that'll probably be another meeting or 2 before it gets to them. And I know some people have great reservations and don't like the proposal, so we're going to have to work through those things for all the reasons we just covered. So that's where that is at. SG14 has also reviewed the second part, which is if you only report runtime errors as exceptions that can be programmatically handled, then don't report precondition violations that way. We should be migrating the standard library from exceptions to contracts for things like out of bounds, for precondition violations, requires, those kinds of things. Turns out that, so SG14 says, yeah, more of that, please. I went to Library Evolution Working Group, presented it. They were very polite and said, we totally agree. They had a unanimous vote and support and basically said, and then I said, go look at the wiki notes for the last 2 meetings where they have basically been unanimously supporting this for 3 meetings already and are actively working in that direction. So basically the punchline for that second one is stood logic error is a logic error.
Yes, it is.
You should not be throwing a logic error. Now, if it turned out there were a couple of uses that were not for preconditions, we'll keep those. But Library Evolution Working Group, who owns that, loves that. So that one's going well and was already in progress. The third one is what about out of memory? This is still being very discussed, is very contentious. I have been amazed at how much support there already is for saying out of memory is not an error that you can handle in normal code. You have to specially write code to do it. Yeah, my code is out of memory safe, nearly always is not true. If your answer includes the word bad alec, you already don't work. I already know your code is not out of memory safe, which is a strong statement.
Right.
So that's a whole thing. That one has, it turns out the Library Evolution Working Group and SG14 love that one too, but that one's more controversial, and then there's a question of migration, because we won't break existing code, so how do you do that? The simplest way would be to set the default new handler, because we already have that. The reason new failures throw bad alec is because the default new handler says throw bad alec, and you can install your own. So we have a one-line hook where we can just say, it calls terminate, and if you want the existing behavior, install a one-liner that throws bad alec, and you can have your existing behavior. So there is a migration path there, but we have to talk about that. That's very early. It has not been talked about in the evolution side, and there are antibodies there on that one in particular. The fourth one actually addresses one of the things you mentioned. So some people don't use exceptions because they can't afford them, because they're too much bloat, or they're not deterministic. But some don't use them because of the programming model, and it's not just because they're writing C code necessarily. It's because we love automatic propagation. This is good, because why do you always want to return error code all the way up? But it is a valid, I totally support and agree with that it is a valid complaint that control flow is invisible. And people say, I don't like automatic propagation, and every single one I've talked to, when you dig into it, and you tease apart automatic versus invisible, they go, oh, well, if it were visible, I'd be fine with automatic propagation. For example, many languages, like Swift and other languages, have try expressions where you just put on anything that could throw, you write try. So the fourth part is to optionally allow people to write try on any expression that could throw. And if it fails, it still propagates. But now you can see in your source code every jump that could happen to the end of the function. And that makes all the difference to people. And then suddenly you start converting a lot of those people who we used to write off as, C-style programmers, to like, oh, no, they were just concerned that they couldn't do their cleanup because maybe they don't use RAI all the time, because they'll forget, because the exception control flow is invisible. As soon as they see it in their code, their comfort level goes way up, because now I can reason about it. And so that's the fourth part of the proposal, and that one has not been discussed very much yet, but that's sort of the summary.
Unfortunately, we're well past time. We got to stop. If we weren't, I would encourage people to read
P0709. 0709.
No, I was going to say read Development Evolution and know why try is in the language at all.
Yes.
Compiler doesn't need try at all. But anyway, we won't do that because we're out of time.
Read Design and Evolution. Bjarne's 1994 book is very 2018 appropriate.
Right. So do we
You could also watch the talk that I did this week where I go into the bit there.
Excellent.
Excellent. All right. Do we need to set up anything about what we're doing in the future? We don't even know what we're doing in the future, do we?
Nope, we're open to ideas.
All right. So we need to cut it off because we're way past time. I want to thank everyone for coming and joining us. Thank you guys all, and I also want to thank our guest Herb, and of course our producer Phil. Thank you guys all very much.
Safe coding.
No safe coding.
Safe coding.
Exception safe coding.
Exception safe coding.